In this video, I am going to explain how different computer specs affect Microsoft Flight Simulator and other games. I am using comparison tables of several PCs that I looked at while deciding what system to choose. The goal is not to recommend a specific computer, but to explain what the differences in specs actually mean in real-world use. In the comparison tables, each row represents a different PC, and each column shows major components such as the CPU, GPU, VRAM amount, system memory, and storage type. Looking at these systems side by side makes it easier to see how small changes in specs can lead to noticeable performance differences. Starting with the CPU, or processor, this is one of the most important components for Microsoft Flight Simulator. The CPU handles flight physics, weather calculations, artificial intelligence traffic, and terrain loading. In the comparison table, some systems use mid-range CPUs while others use higher core, higher clock processors. In Microsoft Flight Simulator, systems with weaker CPUs often perform well while cruising at altitude, but struggle near large airports or dense cities. This can result in stutters, frame drops, or delayed scenery loading. Systems with stronger CPUs tend to handle these situations more smoothly. In many other games, the CPU difference may be less noticeable, but in MSFS, it directly affects consistency and stability. Next is the GPU, or graphics card, along with VRAM. Several systems in the comparison table use similar GPUs, but with different amounts of VRAM. One example is an RTX 5060 Ti with 8 GB of VRAM compared to one with 16 GB of VRAM. In Microsoft Flight Simulator, VRAM is used to store textures, cockpit displays, terrain data, and scenery details. With only 8 GB of VRAM, the simulator can reach its memory limit. You guys are probably sick of this AI video or ones like it. So here's something a little more real. I'm going to load a 737 MAX into Denver International. I have live traffic on, live weather on, and live multiplayer online. All MSFS settings are currently maxed out, so it's 4K and all that good stuff. Alright, we're going to watch the live performance charts as we load into Denver. And right here, we're going to watch this. It's also called dedicated GPU memory. We're going to watch this as we go and load in. We'll see a little spike. It'll probably go up to 15. This is about as hard as you can possibly get on a GPU. You will get that notification when it gets close, but I still have a gigabyte left or gigabyte after that, so it's not that big of a deal. It's just trying to warn you. I've seen that a few times and I have not noticed any sort of stutter in the actual game. Alright, here we go. Everything's loaded. Frame rate is pretty good. We also have our RAM, which is running right at 26 right now. I have 32 available. I have not even came close to maxing this out. As a matter of fact, this is basically the highest I've ever been. But yeah, 32, I would say 32 is the minimum because the other option would be 16. And you could see we would do well past that, right? By now, this is my CPU. I have a Intel Core i7 14700F. F means it's a little older. However, it is 14,700, which basically just means it's powerful. It has 20 cores, which is really good for multitasking, along with AI traffic, live traffic, all that stuff that you heard in the AI video. I'm using very minimal of it right now, about 15-25%. A lot more to be used, but your GPU will limit you before your CPU most of the time anyway. So let's hop into the airplane here. If I click the right buttons, there we go. Let's go ahead and get some screens fired up here. Now let's switch over to VR and see what that does. Okay, now we are currently in VR, as you can see. I can look around. It's interesting because with all the research you do, you would think that the VR usage would actually be higher in VR because it has load so much more. Pretty much everybody says that too. But I have found with the MetaQuest 3S that the VRAM usage actually goes down. I think this is because the MetaQuest is rendering some of its own pixels by itself. It's not using all of the GPU. for the utilization, and the GPU is still 100% because it still has to load the computer monitor. When this happens, the simulator may reload textures frequently, causing stutters, blurry visuals, or sudden drops in performance. With 16 gigabytes of VRAM, more data can stay loaded on the graphics card at the same time. This reduces texture swapping, improves visual clarity, and provides more stable performance. The difference becomes even more noticeable in virtual reality, where the scene is rendered twice and VRAM usage increases significantly. In other modern games, higher VRAM allows higher texture settings and helps prevent texture pop-in large open-world environments. Looking at system memory or RAM, the comparison table includes systems with both 16 and 32 gigabytes. Microsoft Flight Simulator can easily use more than 16 gigabytes of RAM, especially when live weather, live traffic, and add-ons are enabled. When RAM runs out, the system relies on storage instead, which can cause stutters or pauses. Systems with 32 gigabytes of RAM provide more headroom and better stability, particularly during long flights. While many other games run fine on 16 gigabytes, MSFS benefits directly from having additional memory available. Storage is another category shown in the comparison table. This includes differences between standard solid-state drives and faster NVMe solid-state drives, as well as differences in storage capacity. Microsoft Flight Simulator streams large amounts of scenery data, and faster storage helps reduce load times and scenery pop-in. While storage speed does not increase frame rate, it improves overall responsiveness and reduces waiting times when loading airports or starting flights. Larger storage capacity is also important because MSFS and its updates can take up a significant amount of space. By comparing these systems side by side in the tables, patterns become easier to identify. Systems that balance CPU performance, VRAM capacity, system memory, and storage tend to perform more consistently than systems that focus heavily on only one component. The main takeaway is that PC specs should not be evaluated in isolation. Using comparison tables helps show how specific differences, such as CPU tier or VRAM amount, translate into real performance differences in Microsoft Flight Simulator and other games.